The US Air Force has gone gaga for digital acquisitions and model-based systems engineering. If you work in the defense industry, you might hear your boss say something like, "We're doing that MBSE thing now, so I'm gonna need you to figure that out, okay?" And then you're left scratching your head wondering, what does that even mean? How do you MBSE? If this sounds familiar, fear not, you're not alone. So let's demystify model-based systems engineering and why it matters even if you're not an engineer. If you ask trusty old Google, what is model-based systems engineering, you'll find this wordy definition from the International Council on Systems Engineering in COSI. In short, they describe MBSE as the formalized application of modeling to support all of the things systems engineers have traditionally done, and then some. So MBSE is just good old-fashioned systems engineering principles to manage the development of complex systems using modern tools and methodologies that leverage digital models, hence the term model-based systems engineering. So to understand MBSE, you need to understand what a systems engineer does. If we ask the Council of NCOSI, they'll give us this lovely description of systems engineering. Personally, I think of systems engineers as the cat herders of the engineering world. It's their job to wrangle all the other engineers, aerospace, electrical, mechanical, software, etc., to make sure the pieces they're developing in their respective silos ultimately work together as a system. And that's essential when you're developing something complex, like an aircraft. Traditionally, systems engineers manage that complexity by generating a sea of paperwork to capture requirements, interfaces, design decisions, and so on. Of course, in modern times, instead of killing a forest worth of trees, we usually capture that information electronically. But just because your documentation is digitized does not mean you're digitally engineering. Those documents are static, and information does not flow between them. Searching through a mountain of PDFs and Word docs to track down the impact of a design change is still a manual process that's barely better than using old school paper. And this is where using digital models gives us an advantage. So, what do those models look like? A lot of folks hear terms like model-based engineering, and their mind leaps to visions of 3D models for everything and scenes of Tony Stark creating his Iron Man suit. Keep in mind, that's Hollywood. While 3D CAD models are certainly used in engineering, they're not the only kind of model. So we need to broaden our understanding of a model to mean any informative representation of a system or process. So, is that engineer's 3D CAD design a model? Absolutely. But so is the program manager's spreadsheet that they use to calculate costs. These are just different types of models for different purposes. In systems engineering, the models are usually represented as diagrams with different types of blocks and arrows to represent the structure and behavior of a complex system and how its various parts relate to each other and work together. While there are several modeling languages that can be used for MBSE, the most common is the Systems Modeling Language, or SysML for short. It's an open standard which describes what the different types of diagrams and their various symbols represent. To build a SysML model, you need a modeling tool, and there are several of those to choose from, such as Cameo, Enterprise Architect, Windchill Modeler, and Genesis, to name a few. Now, you might be thinking, so what? What makes a block diagram created with fancy SysML tools any better than a block diagram drawn out the good old-fashioned way with pen and paper? While we use diagrams to visualize SysML, under the hood, our system is represented as a digital model. The various diagrams give us, as humans, different ways to interact with that underlying computer model to get different types of information from it. In a way, this is similar to how we look at things in the real world. For example, let's say the Statue of Liberty is our model. There's only one Lady Liberty, so that makes her our authoritative source of truth, or source of liberty. Now, there are lots of ways we can view the statue. Up close, far away, up the nose, from behind. These are all different views of the same model. So, if we give her a mustache, that changes the model, and we'll immediately see it reflected in all the relevant views. The model-based approach to systems engineering enables us to make changes to our design and immediately see the impact it has on the rest of the system. And that lets us play the what-if game all day. What if we use a different engine on our plane? How will that affect performance? Will we need a bigger fuel tank to achieve the required range? And what happens if we use a different flight computer? MBSE lets us evaluate those changes immediately, and that benefit extends well beyond the realm of engineering decisions. For example, as a program manager, you probably want to know what those changes are going to cost. If we've captured the cost of each part within our model, we can automate generating a report to instantly tell us the total cost. The PM no longer needs to go digging through a mountain of documentation to manually piece that together. Now, does this all sound too good to be true? Let's pump the brakes for a quick reality check. While the ideas behind MBSE have been around for decades, with the tools and groundwork being laid, it's only really come into vogue within the DoD over the past few years. Major defense programs are beginning to use MBSE, such as the Air Force's ground-based strategic deterrent. GBSD is an enormously complex missile system with hundreds of ICBMs and launch facilities spread across the country. Thanks to MBSE, the program was able to digitally design and evaluate over 6 billion variants of the system before selecting the one to bury into silos. That's certainly an impressive feat, but it wasn't without growing pains. As the first gigantic Air Force program to really use MBSE, there was still a lot to figure out along the way and plenty of lessons learned. But GBSD has paved the way, and now the Air Force is fully bought into MBSE and digital engineering. In fact, the Digital Building Code, published by SAFAQ in May of this year, declares that any program not pursuing digital engineering principles, which includes MBSE, will need to get high-level approval. This is the way forward, so get ready for it. If you're involved in defense acquisitions, whether you're in engineering, program management, logistics, finance, whatever, this shift to MBSE will impact you. Models are becoming the new way to represent systems and communicate information, so it would behoove you to learn how to use them.